This is a lecture in continuation to the lecture on converting 1. There I gave the concept and I solved some problems over there, and here the remaining problems in the lecture that I will be illustrating the basics or the operation of converting through problems. So, here some more different type of problem as correspond to the converting operation. Now, here is the problem number 3. The problem 3, it says the slag from a copper converter contains the following: the composition of the slag is given, the flux which is charged, its composition is also given, the made charge is 40 tons and carrying 34% copper, or you can say this is the copper grade of the mate is 34%. Now, here as I said in my lecture that it is not necessary that you charge all the fluxes at the beginning. You may charge flux batch wise, that depends on the availability of the infrastructure to charge the flux into the converter. So, this particular problem addresses the issue that the flux is charged in batches. So, the flux is added in batches of 3000 kg, maybe because of some logistics reason they are charging the flux in batches, and the first batch consists of 3000 kg. The converter is blown to slag of the above composition after each addition. So, once you make the addition, the next addition again you make the slag of the same composition as given earlier, and the slag poured off before the next batch is added. So, every time what you are doing, you are adding say 3000 kg of flux, making the slag, removing the slag, again adding 3000 kg of flux, again making the slag and again removing the slag. So, this is going on. The blast has a volume of 100 cubic meter per minute. You are required to calculate time of each partial blow, because now there will be different partial blows will be there. So, how much time for each partial blow, the number of partial blows, because you know the converting, the first stage is slag formation. Only after slag formation stage, that is after the removal of FES, you blow the converter content for production of blister copper. So, first of all you have to know how many number of partial blows will be required in order to accomplish the complete removal of FES, and that is what the problem B says: the number of partial blows and the weight of flux to be added for the last partial blow to produce a slag of the same composition as in the other, because it is possible the last partial blow may not require all amount of flux, maybe less than that. So, you have to calculate that, and the total time for blowing the charge to blister copper, and the total time of course consists of slag forming time as well as blister copper formation stage. So, this is problem 3. What I thought that let me read all the problems, and I will take the solution one by one. So, here is the problem number 4. A copper converter treats per charge 10 tons of 40% matte, that is copper grade is 40%, blast rate is given. Before adding flux, a preliminary blow of 9 minutes is given to produce a magnetite coating. Now, this problem is little different for the converter operation. Here first the problem says a magnetite coating is imparted, which analyzes the composition of the magnetite coating is given. Assume that this is entirely corroded by the end of the slag forming stage. The converter slag carries 32% Fe3O4, 40% FeO, 16% SiO2, 5% CuO. That means what it says, that at the end of coating formation stage, now you enter into the slag forming stage. So, assuming that the composition of the coating, which is Fe3O4, FeO and all is given, it is all converted into a slag which composition is Fe3O4, 40% FeO, 16% SiO2, 5% CuO. The flux carries Cu2s, Fes and SiO2, their percentage are given. The blister copper is 100% copper. The converter gases carry no free oxygen. Now, you have to calculate weight of magnetite coating produced, flux and slag, weight of blister copper, the blowing time and the volume and percentage composition of the converter gases. Now, here I have given the answers for this particular problem, but my request, please see the answer only when you have solved the problem. Now, here is the problem number 5th. In a copper converter, the first charge is 30 tons of 50% matte. The flux analysis is given, slag analysis is given. Now, after the first slag is poured, additional matte is charged, whose amount equals to Fes oxidized from the first charge. Assume all Fe which is not as CuFeS2 is as Fe2O3. The blister copper is pure copper, air is supplied at this particular rate. Now, you have to calculate weight of flux, slag and blister copper, air for the entire operation and the time for first and second slagging period and for blister copper formation. So, let me solve now the problem number 3. So, problem number 3, as usual I make a block diagram. Say here it is given flux that is SiO2 75%, FeS2 5% and Cu2S is 2%. It is said the slag of composition SiO2, Al2O3, CuO and FeO. SiO2 is 32, Al2O3 is 1, is 8 and FeO is 59. So, now we have to calculate the time for partial blow. Now, it is also said MET is 40 tons and its grade is 34% copper. Now, as such, say the MET, we have to find out the amount of Cu2S. So, we can calculate say Cu2S that is equal to 17,000 kg and FeS that is 23,000 kg. You can calculate 34% copper and from that Cu2S and so on. Now, the first batch it consists of 3000 kg flux. Then we can calculate the amount of SiO2, amount of FeS2 and amount of Cu2S that we can calculate. Now, let us say x kg is weight of slag. Then 0.32 x that is equal to 2250, that is SiO2 in flux, it will go to SiO2 in slag. So, from here we get x that is equal to 7031 kg is the amount of slag. Now, let us take y kg FeS of MET, it oxidizes to FeO in one blow. Say we added 3000 kg of flux, now we would like to know how much amount of FeS is being oxidized, because we have to know how many number of partial blows we require in one blow, that is by charging 3000 kg flux. Now, we will do iron balance. We will do now iron balance. So, iron balance that is equal to y into 56 upon 88 plus 150 into 56 upon 120, that is equal to 0.59 into 7031 into 56 divided by 72, where y is the kg of FeS of MET. So, y that is equal to 4963 kg, that is equal to 56.4 kg moles. Now, the reaction which is there, for oxidation reaction you have FeS plus O2 that is equal to FeO plus SO2, and we have FeS2 also, FeS2 plus 2.5 O2 that is equal to FeO plus 2 SO2, because FeS2 is coming from the flux. So, we have to calculate both. So, here the O2 required for this will be 84.6 kg moles, that is for FeS2 FeO, and here for FeS2 O2 required, that will be 3.125 kg moles, because mat contains FeS and flux contains FeS2, and that is why you have to do separate calculation. So, total oxygen for one blow, total oxygen for one blow, that is equal to 87.725 kg moles, or in terms. So, now the time we can calculate, that will be equal to 87.725 upon 0.21, that is the amount of air, into 22.4 upon 100, because we blow 100 meter cube per minute. So, the time is 93.57 minute. So, that is the answer for time for the first blow. Now, the number of partial blows, because you know time for one blow is 93.57, and in one blow you are able to remove 4963 kg of FeS. So, number of partial blow, that will be equal to 23,000 upon 4963, that will be 4.63, approximately we require 5 blow. Now, the fifth blow, in the fifth blow you will not be having 4963 kg. So, in the fifth blow the FeS which is left, that will be equal to 23,000 minus 4 into 4963. So, you require to remove 3148 kg of FeS. Now, you can calculate the flux, same iron balance. So, the flux required for the fifth blow, that will be 1903 kg. Now, again in order to calculate flux, you have to do the iron balance. So, now we can calculate the number of blows. So, we require blow number, you have 1, 2, 3, 4 and 5. All the blows will require 93.57, first blow, second blow also 93.57, third blow also 93.57, fourth blow also 93.57, but the last blow will require 3148 upon 4963 into 93.57. So, that will be equal to 59.40 minutes. Mind you, these are all the minutes. Now, the fifth blow will comprise of 59.40 minutes as compared to all other 4 blows, which consist of 93.57, because you have to remove less amount of FeS. So, that is the say total. If you sum total it, you get the total amount. Now, the blister copper, say blister copper, the reaction is Cu2S plus O2, that is equal to 2 Cu plus SO2. So, we can calculate now the total Cu2S, that will be equal to 108 kg moles, and the time, because 108 kg moles will require 108 kg moles of oxygen. So, one can calculate the time, that will come 115.2 minutes. So, total time would be total time that will be 4 into 93.57 plus 59.4 plus 115.2. So, the total time required that will be 548.5 minutes. So, that is what the answer for this question. So, let us take now the problem number 4, which says about the magnetite coating and so on. So, first of all we have to calculate the weight of magnetite coating, flux and slag. So, it is said that air is 900 cubic meter. It is blown in 9 minutes. So, the oxygen will be 8.44 kg moles that will be available for the formation of the coating. Now, let x kg be weight of coating. Then we do oxygen balance, and from oxygen balance, say we can write down that 2 into 0.75 x upon 232 plus 0.05 x upon 72 into 2 plus 0.05 x upon 2 into 80, that is equal to 8.44. Now, the clue to this problem is that the coating is formed because of the availability of oxygen. So, you have to hit the oxygen balance to get the weight of magnetite coating, and if you do, then the x, that is equal to 1184 kg is the weight of magnetite coating. Now, the problem says further that suppose now once this coating is formed, now the slag formation stage begins, and at the slag forming stage, say we have charged now met 10,000 tons, 40% met, then composition of flux is given to us. It is said that blister copper is produced, which is 100% copper, and slag, its composition is given and it contains Fe3O4, say FeO, SiO2, CO. There all the compositions are given. So, we have to find out weight of slag and weight of flux. So, let us take say m kg slag and n kg flux. So, let us do first of all SiO2 balance. So, SiO2 balance, if you do, it comes 0.16 m, that is equal to 0.52 n. Then we have to do iron balance. Now, here I am seeing oxygen is, I wrote 8.44 kg, in fact it is 8.44 kg moles. So, now let us do iron balance. So, in the iron balance, say iron from FeS of met plus iron from flux, that is equal to iron in slag. So, if you have to do that balance. So, if we do this balance, what we will be getting is a second equation, that will be 3181.8 plus 0.172 n, that is equal to 0.543 m. So, let us take this is our equation 2, and the earlier this was our equation number 1. So, by solving equation 1 and 2 we can get n that is equal to 1998.8 kg, this is the weight of flux, and m which is the weight of slag, that is equal to 6496 kg, that is the weight of slag. So, this is the answer. Now, next we have to calculate weight of blister copper and percentage copper recovery. So, for weight of blister copper, to calculate weight of blister copper, what you will do? You will be doing copper balance. Copper from all sources which is entering and it is leaving, that you have to consider, and if you do that, then the answer, the copper balance, that will come 3788. I think you can do this copper balance because I have done in several other problems, and the percentage copper recovery, say percentage recovery of copper, that is equal to 3788 upon total copper was in the system 4048 into 100. So, that is equal to 94% is the copper recovery. Now, next we have to calculate the blowing time of each stage. To calculate blowing time of each stage. Now, each stage means, as in other problems we have slag formation stage and blister copper formation stage. Now, here prior to blister copper formation stage we have two stages, one is the coating stage and another is the slag formation stage. So, we have to find out what is the blowing time for each stage, right, and that is an important thing, because here the first stage consists of coating. Now, each stage means the stage A is consists of coating, how much time it takes, second stage consists of slag formation stage, slag formation stage. Now, in the slag formation stage you have to consider oxidation of FeS to FeO as well as oxidation of Cu2S to CuO, because you see slag also contains copper oxide. So, in the slag formation stage you have to calculate the time required for complete oxidation of FeS to FeO as well as whatever amount of CuO that is present, that also constitutes the slag formation stage, because Cu2S is also being oxidized. So, you can do those balances and ultimately you have to calculate how much oxygen is required, and from the oxygen you can calculate. So, I hope you can do all this calculation, because this type of calculation have been done earlier. So, I will just write down here the total amount of air, which is required for coating as well as for slag formation stage, that comes out to be equal to 8735.5 meter cube, and the time would be 87.35 minutes, because we are given the rate of blowing. Then we are required to calculate time for blister copper formation, time for blister copper formation. Now, here you know the reaction Cu2S plus O2, that is equal to 2 Cu plus SO2. So, you have to find out how much kg moles of Cu2S has been oxidized in this stage. So, if you do those calculation, so whatever moles of Cu2S, same moles of oxygen would be required. So, the answer it comes kg mole of O2 required, that is equal to 29.59, and from here if you calculate air, that is equal to 3156.7 meter cube, of course at 1 atmosphere and 273 Kelvin, and the time which comes, that is equal to 32 minutes. So, that is the answer for I think part C. Now, the part D says you have to find out volume and percentage composition of gas. Percent composition of gases. So, here you have to find out the volume and percentage composition of in each stage. Say the first stage you have coating stage, you have coating stage. Now, you have to write down the relevant chemical reaction that we have written already. In the coating stage, you have SO2 and nitrogen, because you are blowing oxygen, FES is converted to Fe3O4. So, you have SO2 and N2, and the SO2 will be 12.67 kg moles and N2 is 31.73, they are all in kg moles. So, the percentage that is equal to here 28.5% and here it is 71.5%. So, this is in the coating stage. Now, the gas composition in slag formation stage, SO2 that will be equal to 52.34 kg moles and nitrogen would be 307.93 kg moles. So, the amount, if you sum total both, then it becomes 5, 12, 6 and 360.25 kg moles is the amount of converter gas that is produced. If you want to calculate, you multiply by 22.4, you get the meter cube. So, the percentage SO2 is 14.5% and nitrogen is 85.5%. That is what the amount and the percentage composition of the gases in the slag formation stage. Now, the third stage consists of blister copper formation stage. Blister copper formation stage. Now, here again SO2, it is simple, Cu2S plus, you have already the equation, you have already the reaction Cu2S plus O2. So, 29.59 is the kg moles of O2 and therefore, 29.59 moles will be of SO2 also, because 1 mole Cu2S is giving you 1 mole SO2 or 1 mole oxygen is producing 1 mole of SO2. So, SO2 that will be equal to 29.59 and nitrogen would be 111.26, that is in kg moles. So, if you want to calculate the amount will be 140.85 kg moles and volume will be 140.85 into 22.4, that will be meter cube, and the percentage would be here 21% and nitrogen is 79%. So, that is what the answer for part believe D. This is what I thought of problem number 4. Now, let us go straight away to problem number 5. Now, problem number 5, it is say the charge is 30 tons of 50% met. So, let me represent over here. So, this is the block diagram. Here I am charging 30 tons met, the copper grade is 50%, Now, the flux, it is copper 8, it is all in percent, iron 17%, sulfur 9% and SiO2 that is equal to 58%. Now, the slag which is produced, you have SiO2 27%, FeO 64% and CuO, loss of copper to the slag, it is 4%. And copper, which is the blister copper, I mean it is a blister copper blister or blister copper that has 100% copper. Okay. Now, again for weight of flux and slag and blister copper formation, and also it says that all iron enters into slag. All iron enters into slag. So, first of all we have to do now, in order to find out weight of flux, weight of slag, we have to do SiO2 balance and iron balance as I have done in earlier problems. So, I will be little quick over here. Now, this problem is slightly different. Now, what has been said in this problem is that after the first slag is poured, additional met is charged whose amount equals to FeS oxidized from the first charge. So, that is a slightly different problem. So, here first you have to calculate weight of flux and slag and blister copper. So, as usual say m kg flux and n kg slag. Now, say met, say Cu2s that is equal to 18,750 kg from the first charge and FeS of the first charge that is equal to 11,250 kg, that is the first charge. Now, the second charge, in the second charge met 11,250 kg met is charged. So, the second charge met is 11,250 kg whose grade is 50%. So, we have now Cu2s that is equal to 7,031 kg and FeS that is equal to 4,291 kg, that is the difference here. Now, when you consider the total amount of FeS oxidized, the total amount of slag, then you have to consider the FeS which is charged from both the stages. So, again I will be doing SiO2 balance. So, SiO2 balance that is 0.58 m that is equal to 0.27 n, and I do iron balance. This is from first charge which contains 11,250 kg FeS. So, if you do the balance, I hope you can do it. I am straight away writing the equation 7159 plus 0.17 m that is equal to 0.498 n. This is my equation 1, this is my equation 2, and let me do now iron balance for second charge. If if I do iron balance for second charge, then the equation is 2685 plus 0.17 m, that is equal to 0.498 n, and this is my equation number 3. Now, I can solve equation 1 and 2 and equation 1 and 3 in order to get the amount of slag and amount of flux in each stage. So, if I do that, then the n, that is equal to 17094 kg. This is the amount of slag in the first charge. Then m, amount of flux, that is equal to 7956 kg. This is for the first charge. Now, similarly, by equation 1 and 3, I can now get the n and m. N will be equal to 6411 and m will be 2985. This is slag and this is the flux, which is resulting after charging additional mat. So, the total flux will be the addition of both, that is 10941 kg, and total slag, that will be 23505 kg. So, that is what the answer for that particular part. This is in fact the part A. Now, the B part, you have to find out, even the A part you have to find out weight of blister copper. So, weight of blister copper, it can be easily found by doing copper balance, and this is equal to 20,740 kg. Now, the problem further wants to know air for the entire operation, that means slagging period and blister copper formation period. So, we require now say cubic meter of blast, say in the slag formation stage, we require for oxidation of FeS plus 1.5O2. So, the chemical reaction is this. Another reaction is the Cu2S plus 2O2, that is equal to 2CuO plus SO2. So, these are the two reactions which are occurring in the slag formation stage, where I think I wrote a mistake here. You can put it as slag formation stage. Okay. So, we know that for first slagging period, the slag was 17,094 kg, the first slag, and the flux we needed 7,956 kg. This is what we have calculated. Now, why I have written this thing? Because you have to know FES from MET. So, what is required to know? First, you have to know FES from MET, and then you have to know FES from flux, and then you have to know how much amount of copper is being lost as a result of Cu2S plus 2O2 plus 2CO reaction. This you can find out also by knowing amount of CuO in the slag. Okay? Then you have to find out how much amount of Cu2S is being oxidized to CuO in this stage. So, for that you will be needing the amount of slag as well as amount of flux in the first slagging stage. So, having known all this thing, one can calculate the moles of oxygen, for first stage. I think you can calculate, there is no, it is not at all difficult. You have to calculate all the amount of FES coming from all sources and plus the Cu2S which is being oxidized to CuO. The best way to calculate amount of CuO oxidized is from the percentage CuO in the slag. So, you know how much oxygen is required for that purpose. So, moles of oxygen for first stage, that will be equal to 226.34 kg moles. Now, similarly, you have to find out moles of oxygen for second stage. Moles of oxygen for second stage. Now, same thing here, the total FES oxidized in the second stage, total FES oxidized from all sources, that will be equal to 54.5 kg moles. All right. Then Cu2s oxidized to CuO, that is 1.6 kg moles. Now, having known this thing, now it is easy to find out, say, moles of oxygen in second stage that is equal to 84.95 kg moles. So, this is what the oxygen required for second stage. Now, you have to calculate the air for entire operation, that is what the problem says. Now, the air for entire operation consists of both the Slag period as well as blister copper stage. So, oxygen for blister copper formation stage, the reaction is Cu2s plus O2, 2Cu plus SO2. Now, we have to calculate the amount of Cu2s which is oxidized. You already calculate the amount of copper which is formed. So, whatever amount of copper which is formed in the blister copper formation stage, the same amount of, I mean, in kg moles, because 1 mole of Cu2s is giving you 2 moles of copper. So, you have to take into notice that also. So, from the total amount of copper that you have calculated, if you make it in kg moles and write the appropriate reaction, that is 1 mole of Cu2s is 2 moles of CO, and then you can calculate amount of Cu2s that is required. This is one way. Another way is that how much amount of Cu2s is available for oxidation. So, you know the Cu2s of the mat in both these stages plus copper which is lost in the slag, convert to Cu2s. They both ways you can do it. One way is from copper and another way is from Cu2s. Both way you can do it. So, if you do this, it will come, say, moles of oxygen, moles of O2 for this stage, that will be 162 kg moles. So, now oxygen for entire operation will be sum total of all the three. Oxygen for entire operation, that will be equal to 473.29 kg moles. So, of course, air will be 50,484 meter cube. So, that is the answer for part B. Now, the part C, it wants the time for first and second slagging period and time for blister copper formation stage. So, we can find out, we know the amount of air, and from the amount of air we can find out the time for the respective stages. So, the time for first slagging, time for first slagging time for second slagging and time for blister copper. For blister copper formation stage. So, time for first legging, you know, because the air is blown at a rate of 110 cubic meter per minute. So, time for first legging, you know that 226.34 upon 0.21 into 22.4 upon 110. Here it will be 84.95 upon 0.21 into 22.4 upon 110. Here it will be 162 into 22.4 upon 0.21 into 110. So, the answer would be here 219 minutes, the time for first legging. Time for second legging is 82 minutes and time for blister copper is 157 minutes. So, you look, these are the respective times which are involved in this converting operation. Now, with this three problems which I illustrated today, I have tried to give you the converting operation quantitatively. All different aspect of converting operation I have tried to cover by considering the different type of problem. We have considered the different partial blows, we have considered the charging of met in different stages and so on. So, I hope this will make you clear the converting operation.